Hi guys. So here are the notes from today.
300. Right?
Yes, right. Okay. So for those of you guys who missed it, the law of cosines is useful for when you have SSS or SAS. Okay? Think of the law of cosines as a general formula of the Pythagorean theorem. The Pythagorean theorem, though, only works for right triangles, but the law of cosines works for any triangle. Okay, the rule is, it looks just suspiciously like the Pythagorean theorem, where c squared equals a squared plus b squared, but then you have minus 2ab cosine c. Okay, this one is the big C, the angle C, and this little c is the side C. Okay, so let's actually see what this looks like in action. Alright. Okay. So I have an example here for you. Watch that. Isn't that so cool? Okay. So, for example, let's zoom in a little bit. Oops. Okay. So we have a triangle here. Notice we have, what do we have about this triangle? We have a side. That's ugly. We have a side, and we have a that's ugly too. We have a side 8. We have another side 10.4. We have an angle. Okay, so we have enough. We have SAS. We actually have 2 angles. Now technically you could use the law of sines for this, and we totally could, and in fact that's easier. But I just want to show you how you could use the law of cosines for this. In this case, this would be like your A and your B, and this would be my missing side C. Okay, I called it X, okay? And then the angle that you do know, that would be big C, right? So x squared, or c squared, equals a squared, which is 8, plus 10.4 squared, which is b, minus 2ab, so 2 times 8 and 10.4, times cosine of this angle, which is cosine 15. Alright, ignore the square roots for now. So that means x squared equals 8 squared plus 10.4 squared minus, I did all that in my calculator, I got 11.430 units. And actually, if you're in my 6th period, I erroneously told you that's the answer, but I forgot that that gives you x squared. But now I need to do square root of both sides to find out what x is. Square root of 11.403 is 3.381. So that means this side over here, this little side, is 3.381. Alright, so that's one way you could use law of cosines. Now, let's erase a little bit more. Okay, oops. Okay, just erase that. Ooh, it's like snow. It's like stepping on snow. It's cool. Okay, so this is an example straight from page 55 of your book. This is an example where you know the side. Okay, you know 8, and you know 6, and you know 12, but you don't know any of the angles. You want to know what the angles are. So you can actually use the law of cosines to find the missing angles. And this is how we're going to do it. So I know, let's just call this A, B, and C. It doesn't have to be. Okay, remember, this is when we don't know if it's a right angle or not, but we know that we know the sides. Hola. So you have 12 squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times cosine of u, because u is, okay, so since my side C is 12, the angle across from it, this is my angle C, or in this case we call it u. So whatever is the side we use here, this angle has to be opposite, right? Because in our formula, this C is opposite from this angle C, right? Alright, so 144 equals 64 plus 36 minus 96 times cosine of u. Okay, I added 64 and 36. I got 100. I subtracted 100 on both sides to get 44 equals negative 96 over cosine of u. Of course, you could divide 96 on both sides, reduce, and you get a negative 11 over 4. 24 equals cosine of u. Now, this is the critical part. If I know that cosine of some mystery angle gives you this ratio, if I know the ratio and I'm trying to figure out the angle, I'm not really cosining it, I'm uncosining it. I'm doing the inverse. So if I do cosine inverse of the ratio, I should get the angle. So in my calculator, I'm going to do cosine inverse. That's shift, right? Or second. On your calculator, you put second plus sine, and then you're going to get the sine inverse of that negative fraction, and you're going to get this angle, 11.73, which tells you that angle C here, this angle over here is 117.3 degrees. Okay? You use a similar inverse cosine situation for your homework problem. That extra worksheet I gave you. Let me see. The extra worksheet. Thanks, Richard. Number 1 on the back of the extra practice worksheet I gave you, you're going to use, if you notice, I'm just going to do it real quick over here. So number 1 on the back of the 1.3.2b worksheet, you're going to set up your ratio. Basically, you're going to say sine of 92, this is law of sines, okay, over 15, this is using law of sines, equals, we don't know what that triangle of z is, so angle sine of z over 7. Okay, so if I cross multiply, 7 times sine of 92 equals sine of z, oh, yuck, equals 15 times sine of z. If I want to get sine of z by itself, I divide by 15 on both sides. Okay? And so basically, sine of z equals all of this, right? Sine of z equals all of that. 7 times sine of 92 divided by 15 on my calculator. If I do that, you can follow along with me if you want, but everyone's going to be lazy and not do it, but I know. 7, la, la, 15, la, la, la. Okay, so it equals 0.46638. Oh, you're actually following along. Cool. All right, so if sine of my mystery angle z equals this ratio, then the sine inverse, or the arc sine of this ratio, okay, which I'm just going to keep in my calculator so I could be as accurate as possible, gives me my angle, which if I do sine inverse of that answer, I should get 27 approximately 8 degrees. Okay, and that is my answer. So you have to use sine inverse when you don't know the angle. Alright, if you have other questions on your homework, well, do your best. And can message me if you need to. But yeah, good luck. I know I gave you a lot of homework, but we do have a lot to cover, so suck it up and do it. Thanks. Okay, bye.